part 2. We begin part 2, which in a lot of ways is maybe the more challenging, but at the same time, it's the one that will just kind of go over, I think, 2 big ideas here. And I think it's going to be really helpful to understand how to do these with the chain rule. All right. So in the previous video, we talked a lot about ignoring everything on the inside and then taking the derivative of the outside first, and then you can take the derivative of the inside and put it out here. And that concept is the same when we deal with e to the x or sine and cosine. So for example, we have e to the 3x. Well, we know the derivative of e to the x is e to the x. This does not change. This is always true. It's the only function that when you take the derivative of itself, you get itself. So if I was to take the derivative of this, okay, I'm still just going to get e to the 3x. But keep in mind, we have to take into account this 3x. So derivative of e to the 3x is e to the 3x. Now multiplied by, well, now you have to still take the derivative of this input, the inside portion. What's the derivative of 3x? Well, it's 3. And so we get f prime of x is equal to 3 e to the 3x. And there's your derivative function. Going to problem number 10, well, if I take the derivative of this function, well, it doesn't matter. E to the 4x stays the same. So derivative of e to the 4x is e to the 4x. But what's the derivative of the 4x though? It's just 4. And the derivative of 2 is gone. So we get f prime of x is equal to 4 e to the 4x. And that would be the function there. Just to show you, these derivatives stay the same. They will not change. Okay. Let's go to 11 and 12. Okay, well, what's the derivative of cosine? Derivative of cosine is negative sine, and we get e to the x. And now we just take the derivative of the inside. Okay, it's the same kind of concept. Well, what's the derivative of e to the x? Which is e to the x. So we get f prime of x is equal to negative e to the x sine of e to the x. There it is. All right, over here, let's go ahead and do number 12. F prime, what's the derivative of cosine? Well, negative sine. Ignore the parentheses, the inside portion, your input. Now take the derivative of the input, which is 2x. Derivative of 2x is boom, 2. So f prime of x is equal to negative 2 sine of 2x. It's mathematics. Matter of fact, it's acrobatics. We'll be flipping and reflecting over the x and y axis. All right, my friends. Here are the ones that I will consider to be maybe the most challenging. And the best way to think of these is how they work. So anytime you have, let's say this, sine of x squared, we can write this as sine squared of x. Okay, anytime the entire thing is squared, you can put this to like right here, right before your parentheses of x. This is just notation wise. So if I want to take the derivative of this, okay, the best way to do this is going to be to write this as sine parentheses x squared plus 1, and maybe I'll put brackets or whatever you prefer and put it to the third power out here. This 3, if I was to rewrite it, always goes in front here whenever you see that 3 right next to that sign. Okay, now if I take the derivative of this, we'll ignore everything on the inside, bring the 3 down, and we're going to get f prime of x is equal to 3, okay, sine x squared plus 1, subtract 1, we get 2, times, now we work our way inside, right? Now we ignored everything on the inside, now we work our way inside. Well, what's the derivative of sine? Well, we get cosine, and we ignore this part here, and we get x squared plus 1. Now you have to take the derivative of this inside because we haven't dealt with it yet, and that's just 2x. So finally, we can rewrite this problem as, well, there's a 3 out here and a 2 here, so I could write this as 6x parentheses sine x squared plus 1 squared times cosine of x squared plus 1. Or, last but not least, I could rewrite this as 6x times sine, and I can put the 2 back in this notation here. X squared plus 1 times cosine of x squared plus 1. And this would be my derivative function. Notice that it required the chain rule a multitude of times, and that's okay. Sometimes we're going to deal with stuff like that. So let's look at the problem to the left. So let's go ahead and rewrite this to be, I'll just go ahead and write cosine of x squared plus 1, and I'll put bigger parentheses or brackets, it's up to you, squared. Bring the 2 down, ignore everything on the inside, so we get cosine of x squared plus 1 to the 1 power. And now we work our way inside. What's the derivative of cosine? Well, it's going to be negative sine. And we ignored that parenthesis for now, x squared plus 1, like such. Now what's the derivative of this inside? Well, it's 2x. Boom. Okay, to simplify this through, we got 2 times 2, which is 4, but we have this negative, so that's going to become negative 4x. And we're going to get cosine of x squared plus 1 times sine of x squared plus 1. And there it is, your derivative function. Notice, my friends, it's going to take a little bit of practice. They're very challenging problems. Okay, now let me show you the difference here. Do you see how the 2 in this problem is now outside this parentheses and the 2 is not in here? There is a big difference. And let me show you what that means. Anytime you see a 2 in this inside here, that's within the function. So I would like to write it like this. I'll put an extra set of parentheses and we get 3x plus 1 squared and close the parentheses. Okay, it's not the whole thing squared, it's just the inside is squared. So I like to just go ahead and put an extra set of parentheses like that. Okay, because the 2 is attached to the 3x plus 1. So if I was to take the derivative of this, I would get derivative of sine is cosine. Leave everything on the inside alone, 3x plus 1 squared. Now we work our way inside. We'll take the derivative of this. And I'm going to get 2 by bringing the 2 down, ignore everything on this inside, 3x plus 1 to the 1 power, multiplied by, now you can take the derivative of the 3x plus 1, which is going to be 3. Whew. And last but not least, we are going to get, okay, 2 times 3 is 6, so we're going to get 6, 3x plus 1, like that, times cosine, parentheses, 3x plus 1 squared. Boom. These are the most challenging ones, and the more practice we get with these, the better off we're going to be. So let's take a look at number 14 here. Notice where the 3 is at. The 3 is not in front of the cosine, so you know it's not the entire thing to the third power. It's just an extra set of parentheses there. So we get 4x plus 1 to the third power. And now we'll go and work our way on the, start with the outside. What's the derivative of cosine? My friends, is going to be negative sine. Leave everything on the inside alone. 4x plus 1. Forget my 3 there. Now we can work inside. Take the derivative of the inside. So we're going to get 3 parentheses. Leave the inside alone here, squared, times now the derivative of this, which is just 4. And negative times 3 is negative 3, times 4 is negative 12. So negative 12. 4x plus 1 squared times sine of 4x plus 1 to the third power. Boom. And there it is, my friends. Okay. Very tricky stuff. Again, just to set you up here, take a look at this problem number 13 here. Okay, let me just scroll up, very similar to just what we did up here. Actually, they are identical to each other. I made them minor. I probably just copied them on there multiple times, but I want you to notice, okay, that's the big difference between those two. The 3 here is in front of the sign. That means the entire thing. So I would write this as sine of x squared plus 1, all raised to the third power, okay? Versus if you put the 2 out here, like such, well, that means you're going to have to do cosine parenthesis x squared plus 1 squared. Okay, that's the difference between the two when you see the 3 or any number in front of the sine or the cosine versus when it's outside of the parenthesis. Hopefully that makes sense. It's going to take a little bit of practice, but that's the most challenging aspect of the chain rules when you have to do it multiple.